In this video, we're going to talk about Markovnikov's rule in reactions. So let's imagine that we have this compound and that we react it with HBr. The products that we're going to get, since this is the double bond, the bromine could either be on the left side of the double bond or it could be on the right side of the double bond, and it would actually be, the product would be a combination of these two, and each one would be 50%, about 50% of the solution. So that's not really, it's not really going to matter where you put the bromine. However, if we have a reaction with this and we have the bromine in there, one of these outcomes is going to be favored, and that's what Markovnikov's rule is about. So on the left hand side, when we draw bond line structures, we generally don't include hydrogens because it would take too long to draw. However, I'm going to do that for the sake of this. So each carbon is supposed to have 4 bonds, and so I'm going to draw, so this one has bonded to 4 things, or bonds to 3 things drawn, so there should be 1 extra hydrogen so that it can get to 4, and here it was bonded to 2 things, so there must be 2 extra hydrogens to get to 4. Now when you react it with the hydrogen bromide, the hydrogen is going to go on the side that has the most hydrogens already. So the way to think about it is the rich get richer, right? And richness, I guess, is how many hydrogens you have. The carbon with the most hydrogens is going to receive the remaining hydrogen. So in this situation, the bromine is going to be on the left side of the double bond because the left side of the double bond has the least hydrogens, and that's where the halogen is going to go. Now let's talk about a situation where you can have this alkene, and the solution which you're going to put it in looks something like this. In this situation, you are going to have Markovnikov addition. So these two are going to add with Markovnikov, and specifically you're adding the water. And specifically what happens is water looks like this, but when you do this addition, it's going to have 2 parts. It's going to have the OH and it's going to have the hydrogen. So when this double bond, when it breaks, it leaves extra spots in here. And as we talked about, this hydrogen on the right side is going to have 2. This carbon on the right side is going to have 2 hydrogens. The one on the left side is going to have 1. So the hydrogen is going to come to this one, and the OH is going to go to that one. So our final product looks like this. If we react this same compound with different solution, where we have we're actually going to get what's called anti-Markovnikov addition. So as opposed to the hydrogen going to where there are most hydrogens, it's going to go where there are least hydrogens. So anti-Markovnikov would be the poor getting richer. So in this case, the OH is going to go on the right carbon. Now let's practice with another example. say we have the same compound, and then we react it with HBr under a peroxide. So whenever you have this, it means it's reacting under a peroxide, and whenever it's reacting under a peroxide, it's going to do anti-Maokovnikov addition. So the bromine is going to go on the carbon with the most hydrogens, which is the carbon to the right of the double bond in this case. Now, if you were to do this reaction without the peroxide, you're just going to end with Maokovnikov addition, which would mean that the hydrogens would go to the carbon with the most hydrogens already on it.